So for today's lecture, we will be doing section 2.3 of our course, and this is titled Factoring. So first, I just want to say that one of the more difficult problems in mathematics involves factoring. Okay, and I will show you a little example why factoring is one of the difficult problems. So for example, let us consider the integer case. Okay, so given two integers, 31 and 29, we can easily compute for their product. Okay, we can use calculator, we can do it manually, etc. So if we try to compute the product of 31 and 29, this will be equal to 899. Okay, now the two numbers on the left side, so you have here 31 and 29, we call them factors of the number on the right hand side. Okay, so you multiply two numbers, so each of the number is called a factor. Okay, now let us reverse the problem. Suppose we start with 899. So can we easily think of those numbers whose product is equal to 899? Of course, we have the example in here already. So we can easily say, oh, it's 31 and 29. Okay? But what if we make it harder? Okay? So suppose we are given the number 899, find two numbers whose product is 899. So how about this? How fast can you get the factorization of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0? 899 here is just a small number. And yet, if you started with 899, you will have to find the, the factors, okay, of or the factorization of the number 899. Okay, but what about for large numbers? Okay, so how do we how fast can we get the factorization of those large numbers? So this number here can be factored into the following. So you have 2 times 3 squared times 5 times 3,607 times 3,803. Okay? So this number here on the left can be factored using these numbers on the right. In fact, if you multiply all of this, we will obtain this number on the left. Okay? If you were able to get it fast, good for you. But honestly, I myself won't be able to get this factorization as fast. Okay? I would have started dividing this by 2. It's easily seen. And the next prime number that I can use is 3. And then I will have to try 3 again, and I will have to try 3 again, etc., etc., until it's no longer possible. And then I will go to the next prime number, which is 5. So I will try 5, okay? And then it will be divisible for the first time. But for the second time, I will try 5 again, and I won't get any factor. And then I will try 7, I will try 11, I will try 13, etc., etc. So after dividing by 5, the next number that can divide the number, this left-hand side, okay, is 3,607 already. And that's really hard to find, okay? So by this example, I hope I was able to at least um, uh, show you that factorization or factoring is one of the harder problems in mathematics. And in fact, if factoring is an easy problem, then we would have able to um, identify all the prime numbers. Okay, there are infinitely many prime numbers, but we don't know yet all of them. Okay, and if there is a technique on how to do that, then factorization should have been easy. But no, this is one of the oldest problems and one of the hardest among those problems. Okay, so what we're going to do is factoring polynomials. So we will not do that integer case. So we will deal with polynomials. Okay, the integer case, it's just the polynomial of degree zeros. Okay, all the constants. But in here, we will deal with polynomials of degree 1 or of degree 2 or of degree 3, etc. So our goal is to factor polynomials. Okay, so for example, let us consider this product on the left, 2x minus 5 times x plus 2. So same process as in before. We can multiply these two polynomials and we will end up with 2x squared minus x minus 10. Okay? So the two polynomials on the left side, so this polynomial here and this polynomial here, they are called factors, just like in the integer case. So they are called factors of the polynomial on the right. Okay? So the process of finding factors of a given polynomial is called factoring. Okay? So our goal is, suppose we are given this polynomial on the right, how can we write this polynomial on the right as a product of its prime factors? Okay? Or as a product of its factors. Okay? We will only consider factoring polynomials in one variable, okay? Into products of polynomials in one variable, of course, where all coefficients are integers. So our polynomials will only have integer coefficients. Okay? And we call this factoring over integers, which means that if we want to try to factor a polynomial, the factors, okay, the factors of that polynomial must have integer coefficients also. Okay? Must have integer coefficients also. Now, any polynomial can be written as a product of 1 times itself, or as negative 1 times its additive inverse. Or simply, your p of x, this is your polynomial. This can be written as 1 times p of x, or you can write p of x as negative 1 times negative p of x. Okay, so negative here multiplied to negative here, it becomes positive. So you will get the p of x. And this is the most obvious factorization. But we will not consider this type of factorization. We want a more, say, difficult, quote unquote, factorization, because this is the trivial factorization. Okay? So if a polynomial cannot be written as a product of two other polynomials, excluding 1 and negative 1, okay, excluding 1 and negative 1, we say that the polynomial is prime. Okay, just like in the integer case, you have your prime numbers, 2, 3, 5, 7, etc. They are called prime numbers if they can only be uh, written as a product of 1 and the number itself. Yeah? So the same thing with polynomials. But here, we include negative 1. So 1 and negative 1. Okay? So if a polynomial cannot be written as a product of two other polynomials, excluding 1 and negative 1, we say that the polynomial is prime. So for example, these are some polynomials which are prime. So ax plus b, okay? If a and b are integers and do not have a common factor. So specifically, say you have your 2x plus 3. Okay? So let me just write it here. So 2x plus 3, this is a prime polynomial. Okay? Because 2 and 3, they don't have common factors. Okay? And 2x plus 3 is now a prime polynomial. Or maybe we can have what? 3x plus 10. Okay? 3 and 10 do not have a common factor. So 3x plus 10 is a prime polynomial. Okay, question so far. Another example, another type of polynomials here. Okay, or another example of prime polynomials. You have ax squared plus b. If a and b are integers and do not have a common factor. So you have your 2x squared possibly. So you have your 2x squared plus 3. Okay? Or maybe 2x squared plus 1. This is also prime. Okay? Although, of course, 2 and 1, 1 is a common factor of 2 and 1. But anyway, we will exclude that 1 and negative 1 as a common factor, right? So 2x squared plus 1 or 2x squared plus 3 and etc. So pairs of A and B which do not have a common factor, excluding 1 and negative 1. Because 1 and negative 1, they they are always common, okay, to any two numbers. But again, we are excluding them. Okay? Now, let us see. If the polynomial has been written, okay, as a product consisting only of prime factors, we say that it is factored completely. So this is our goal. We are given a polynomial. We want to factor completely that polynomial, meaning we should be able to write it as a product of prime polynomials only. Okay? So, first step in factoring, or the easiest technique in factoring, is to identify common monomial factors. Okay? So for example, you have your 3x plus 9. Notice that 3 and 9, they have a common factor. 3 is a common factor. Okay? So monomial, common monomial factors, the first monomial here, it's 3x. The second monomial here, it's 9. But here, your 9 can be written as 3 times 3. So notice, you have 3x, and then you have 3 times 3. 3 is a common factor of the monomials that appear here. Okay? And therefore, this 3x plus 9 can be factored into 3 times x plus 3. Okay? So this is the factoring. And remember, we did something like this in the previous lecture in the form of distribution. So from this, okay, from this side, if we distribute it, it becomes 3x plus 3 times 3. Okay? But this time, we are now reversing the process. From this side, from the left side, going to the right side, we are factoring. That's the reverse of your distribution. Next, you have 2x minus 12. So 2 and 12, they have common factor. 2 is actually a common factor. So in here, you can write 2x minus 12 as 2x times 2 times 6. So 2 is a common factor, and therefore, we can factor out that 2 so that 2x minus 12 can be written as 2 times x minus 6. Okay? And by the way, x plus 3 cannot be factored anymore because here you have 1 and then you have 3 here, and 1 and 3 do not have a common factor except for 1. Okay? Same is true with x minus 6. Cannot be factored anymore because you have your 1 here and then your minus 6 here. Okay? They don't have a common factor except for 1 or negative 1. Okay? Remember that we exclude those numbers. Okay? Now, look at this. 4x squared minus 8x plus 16. So you have a trinomial here, but look at each monomial. For x squared, you have minus 8x, and then you have 16. So looking at the coefficients for negative 8 and 16, okay, those coefficients have a common factor. 4 is a common factor because 8 is 2 times 4, 16 is 4 times 4. So this polynomial here can be written as 4x squared minus 4 times 2x plus 4 times 4. So 4 is a common factor. And therefore, we can factor out 4 to get 4 times x squared minus 2x plus 4. Okay? Now, at this point, believe me that this guy here, x squared minus 2x plus 4, is already a prime polynomial. So later, we will know, we will have a technique on how to know that a given degree 2 polynomial is already prime. So for now, believe me that this x squared minus 2x plus 4 is already a prime polynomial. So questions so far? Okay, let us continue. You have your x cubed plus 3x. So notice you have x cubed here, and then the other monomial, it's 3x. So we don't look at the coefficients. We now look at the variable x. So this has x, this also has x. And therefore, x is a common factor. X cubed can be written as x times x squared. And then you have here plus 3x. So you have the x here. And therefore, you can factor out that x. And you can write this as x times x squared plus 3. Okay? Here, x squared plus 3, according to one of the remarks earlier, this is already a prime polynomial. Okay? This is already a prime polynomial. So I don't have to impose to you that this is a prime polynomial, unlike this guy here, your x squared minus 2x plus 4. Okay? I am asking you to believe that this is a prime polynomial. But for this, we had a remark earlier. So, yeah. Okay?
Okay.
Yep. Next example, you have x to the 4 minus 5x cubed. So looking at this, you have x to the 4, and then you have x cubed in here. So this x to the 4 can be decomposed into x times x times x times x. Or you can decompose this as x times x cubed, which means that written that way, x cubed times x, and then the other guy, minus 5x cubed, x cubed is a common factor. Okay? And therefore, we can write x to the 4 minus 5x cubed as x cubed times x minus 5. Okay? You might ask me that can we separate that x cubed, or can we write that as x times x times x times x minus 5? Yes, you can, but in this case, we apply laws of exponents. Okay? We use the highest common factor among them. Okay? Which means this part here uh, can be written simply as x cubed. Okay? So this will be our final example. So the final answer, I mean, this guy here. Okay? And this is considered as the complete factorization of the polynomial x to the 4 minus 5x cubed. Another example. Here you have 4x squared minus 6x. So for this, first, your 4 and 6. Here, 4 and 6, they have a common factor. 4 can be written as 2 times 2. 6 can be written as 2 times 3. So 2 is a common factor. Furthermore, x squared and x have a common factor, x, because x squared can be written as x times x, and of course, x is just x, which means that this guy here, we rewrite it as 2x times 2x minus 3 times 2x. We clearly see that 2x are is the common factor, and therefore this polynomial here can be written as 2x times 2x minus 3. Okay? You can work longer on this polynomial by, say, you can start maybe by looking at x only. So here, say you have 4x times x and then minus 6 times x. So that you might be able to write that this is now x times 4x minus 6. And then you will realize, 4 and 6 have a common factor. And then you do the factoring again in that part. So maybe you will write here as x, and then you will have 2 times 2x minus 2 times 3. Okay? Let me change the color of this. And therefore, 2 here is a common factor. Okay? 2 here is a common factor, and therefore, we can write this now finally as 2x times 2x minus 3. Okay? You can do this solution. But again, you will have added steps. Unlike in here, okay, what we did in here is to combine these two steps here. Okay, these middle steps here. Okay, so it's up to you how you're going to work on that. There's a possibility that you will do this, okay, especially for harder polynomials. Okay, and when we are using other techniques, there's a possibility that you will need to do that. Okay. Question. So these are examples of factoring by identifying common monomial factors. Okay?
I have a question.
Yes?
Uh, we need. Can I write just like 2x? Like in the last you write.
Here?
We need to write everything like this. How you did.
No. What you can do, actually, you can skip these middle parts. So from 3x plus 9, you can just immediately write 3 times x plus 3.
Okay, thank you
Or
very
in
much.
here, 2x minus 12, you can immediately write 2 times x minus 6. So
So
this part here is just for illustration.
in exam, I can write right away, yeah?
Yes, of course.
Okay,
Of
thank
course.
you.
You can write right away.
Mhm.
Okay?
Thank you.
You're welcome. Other questions? So let us look at the next way of factoring for some polynomials. So factoring the difference of two squares and some difference of two cubes. So remember we had a formula for obtaining the difference of two squares. There is a particular um, form to get that difference of two squares. Okay? So we will get that again. And another set of formulas that can let us factor cubes. Okay? So in here, for any integer a, so the difference of two squares, x squared minus a squared, this can immediately be factored into x minus a, x plus a. Last meeting, we started with x minus a times x plus a, and we will end up with x squared minus a squared. Okay? So this is the same formula as in the last meeting. What we're going to add for this part are this. Difference of two cubes. So x cubed minus a cubed. Okay? And then sum of two cubes. So x cubed plus a cubed. So minus and plus. Okay? And then you might ask me, sir, why is there no x squared plus a squared? The thing is, x squared plus a squared is no longer factorable. It's a prime polynomial. Okay, so we don't have that. Okay, unlike for the cube, x cubed plus a cube, we have a factored um, form. Okay, so in here you have your x cubed minus a cubed. This is equal to x minus a, okay, times x squared plus ax plus a squared. So look at this middle. It looks like your square or your squaring binomials, except that there is no 2 in here. Okay, there is no 2 in here. Okay, and then for your x cubed plus a cubed, this is equal to x minus a times x squared minus ax plus a squared. Okay, the difference is if you have minus here, you got x minus a, and then the other factor has both plus. And then you reverse it if you have your x cubed plus a cubed. So here you have plus, and then for the other factor, you have alternating signs, plus, minus, plus. Okay? And I know this formula here, it's not easy to memorize for, of course, for for students beginning to learn mathematics. So I will be including this if needed, okay, during exam. Okay? So these are the examples that we're gonna work on off the record. So just look at that or pause or hit pause or copy them. Anyway, they are already in your notes, so just write the solution as we go. Okay, so let us continue with the next factoring perfect squares. So remember, you had so last meeting we had squaring binomials. So this time we are going to reverse the process. So from squaring binomials from last meeting, this time we should be able to identify that the polynomial is actually a square of something. Okay? Doing this method here is not as easy as the previous ones. Okay? Now recall, for an integer a greater than 0, you have x minus a squared. This is equal to x squared minus 2ax plus a squared. So from left-hand side going to right-hand side, you just square it. And here you have x plus a squared. It's equal to x squared plus 2ax plus a squared. So the problem for us now is we reverse it. We reverse it. So from this right-hand side, how do we get the left-hand side? Okay? So we will see how we're going to do that. And these are the examples that we're going to work on. So the next way of factoring is by grouping. So in this method, okay, if a common factor cannot be found in every term of the polynomial, but occurs in each of several groups of terms that make up the polynomial, then the common factor can be factored out of each group using the distributive law. So earlier, the first method that we have, that we had, factoring by uh, identifying the common monomial. So in this case, if we cannot find it, we cannot find the common factor on each monomial, what we can do in this way is we group the terms. Okay, we group 2 or 3 monomials, and then we try to check if that group is a common factor of the remaining ones. Okay, so grouping. Okay, so this technique is called factoring by grouping. So for example, in here we have these 3 examples. Okay, next method, factoring a second degree polynomial. This method here, it's a bit easier compared to factoring by grouping. Okay, I mentioned earlier that when you do factoring by grouping, um, I wrote the composition of the middle part. But what if I simplified that? Meaning we only see this form here. Okay, so this is what we're going to do. To factor a second degree polynomial x squared plus bx plus c, the goal is to find integers a and b. Okay, integers a and b such that a plus b equals capital B, and then the product AB is equal to capital C, and therefore this x squared plus bx plus c can be factored into x plus a times x plus b. Okay, so the middle part is a sum of 2 numbers, that middle coefficient, and then the constant part, it's the product of those 2 numbers. Okay, so look at these examples. Okay, I will do on the record the first 2 examples here. Okay, and then the third and the fourth example will be done off the record. Okay, so first, x squared plus 5x plus 6. So in here, capital B, it's 5, capital C is equal to 6. In order to do this, you start with capital C. C is equal to 6. Okay, your C must be equal to AB, the product AB. Okay? So your C must be equal to the product AB. So you can list down possible values of A and B. And once you have those possible values for A and B, you now check, is A plus B equal to capital B? Okay? Okay? So 6. Your C is always 6. Your C is always 6. So what are the possible factors of C? A, B in here. So it could be 1 and 6. Your A equals 1, your B equals 6. Now, is 1 plus 6, that's your A plus B, is 1 plus 6 equals B? In this case, B equals 5? No, because 1 plus 6 equals 7. So this here is not, or this pair here, A equals 1, B equals 6, is not the one we are looking for. Next, we have, so it's not appearing in your screen. Yes, so we have 6 here, but that's your C. And possible A and B's, -1 and -6. Because -1 times -6, that's still +6. And you check if these are your A and B. Is A plus B equals capital B? No, because -1 minus -6 is a negative number. Okay? And it will never be equal to 5. Next pair, 2 and 3. So 6 is equal to 2 times 3. So A equals 2, B equals 3. You check, A plus B, 2 plus 3, it's equal to 5. Yay! We have your A and we have your B. That's it. And you now have your factors. Okay? But for the sake of checking the other pairs, you can also have -2 times -3. -2 times -3, that's +6. But this pair here, -2 minus 3, that's -5 and not +5. Okay? But what do we have now? This row here gives us that A and B that we want, meaning your x squared plus 5x plus 6 can be factored into x plus 2 times x plus 3. Okay? So this method here is actually easier compared to your grouping. You look at the constant part, it's a product of two numbers. So you only need to check all the prime factors of the constant part, then you pair them. Then you check if the sum of your pairs are equal to B. Okay?
I have question.
Yeah, go ahead.
Why it's not 4 and 1? How we know it's 2 and 3?
Because 4 times 1 is what? What is 4 times 1?
Okay.
You need
Visible.
the
So
product to be equal to 6. You need those
so we
pairs.
need to multiply A.
Yeah, you have to multiply A and
Okay.
B.
Okay.
Yeah, because this is the condition.
Mm-hmm.
This is the condition. Okay?
Okay. Yes, thank you.
Okay, you're welcome. Let us look at the next number, next item. Factor x squared minus 7x minus 8. So in here, look at this. Your B, it's minus 7. Your C, it's minus 8. Take note, the form is x squared plus bx plus c. So if it were minus, then the negative is also included in the B. And here negative,
Excuse
it's
me, can you
already,
please
yep.
Can you just previous slide? I wanna just take note a little bit.
Okay. Let us wait for the screen to appear. For some reason, it's lagging. Yeah,
Thank you.
you're welcome. Okay. So this time, we still do this. So I'm just writing it here. But our C, it's equal to -8. So what are the possible values? You have 1 times -8. That's your -8. Then we check A plus B. So 1 plus -8. And in our first try, we are lucky. 1 minus 8, it's already -7. The B that we desired. Okay? And we are done with the factoring. You don't have to check other factors. Okay? There are other possibilities. Let me just write, or let me just show the other possibilities. -8, it's also -1 times 8. But -1 plus 8, it's not equal to -7. -1 plus 8, it's +7. So this is not what we wanted. -8 is also 4 times -2. But 4 plus -2, this is +2. The other pair, -4 and 2. So negative 4 plus 2, this is -2. It's not equal to -7. So we are lucky that in our first try, we got our answer. Okay? And therefore, we can factor x squared minus 7x plus 8 into x minus 8 times x plus 1. Okay? So we now look at a second degree polynomial of this form. So what if we have that coefficient a, and a is not equal to 1, unlike in the previous method? So in this form, so to factor a second degree polynomial, ax squared plus bx plus c, when a is not equal to 1, and a, b, and c have no common factors, this is how we do it. Find the value of the product capital A times capital C. Okay? Once you have that, you find a pair of integers A and B, small a and small b, such that the product small b equals capital A, capital C. So what's the difference? Earlier, your A, it's equal to 1. That's why we only have C. This time, if A is not equal to 1, we look at AC. That should be the product AB, the small a times small b. And still, you have the same a plus b equals capital B. Okay?
Why
And
have, sorry,
yes,
why it's a not supposed to be one?
because we already had the case when a equals 1. It's these cases, right? When a equals 1, it's
Mhm.
this case. So we have a method.
Also, we need to find numbers. If we put one, it's no numbers, yeah?
Not really no number. It's just it's invisible in a sense that any number multiplied to 1, it's itself.
So we need to be visible.
Yeah,
Okay, that's it.
if
Thank you.
that's it's yeah, there should be some other number attached to x squared. Yeah,
Okay, thank you.
you're welcome. Now, so you need to find integers a, b such that so you need to find a pair of integers small a and small b such that the product small a times small b equals capital A times capital C, and such that small a plus small b equals capital B. Now, here's the additional step. You have to write, since you were able to write small a plus small b equals capital B, you will decompose the middle. So capital Bx, you will now write it as ax plus bx. So small ax plus small bx. Okay? And then after this, factor the expression by grouping. You can group this and then you can group this and you will be able to find the answer. Okay? So here are the examples that we will solve. So 3x squared plus 4x plus 1, 3x squared plus 10x minus 8, 6x squared plus 5x plus 1. Okay? Let us do this on record, all of them. So 3x squared plus 4x plus 1. So our capital A, it's 3. Capital B, it's 4. Then capital C, it's 1. Okay? So this is your capital A, this is your capital B, and this is your capital C. So we look at AC. We need to find the value of A times C. So 3 times 1. So AC, that's 3 times 1. That will be your AB. So in here, take note, 3 times 1, that's your AC, it's your 3. So possible A and B, we have 3 and 1. Okay? And then if you add 3 and 1, you will get your 4. And we are done with your small a and small b. So this is your small a, this is your small b. Okay? Step 3. We write now this expression decomposing a small a and small b. So 3x squared plus 4x plus 1 can be written as 3x squared plus 3x plus x plus 1. Okay? So this is your a here, and then this is your b here. So small a and small b. So this is your small b, this is your small a. So that's this step 3. And then you do this by grouping now. So you can group 3x squared plus 3x, and then you group x plus 1. So now you have 3x squared plus 3x plus x plus 1. And looking at this group, 3 is a common factor. X is also a common factor. So you will get 3x times x plus 1 because 3 is a common factor. This is your 3. X is also a common factor. This is your x. So what remains inside? It's x plus 1. And look at this. This is already x plus 1. So as a whole, okay, as a whole, x plus 1 now is a common factor. And therefore, you can factor this into 3x plus 1, x plus 1. So again, this is your 1 here. Okay, so this guy and this guy here will be this part here, 3x plus 1. And of course, this guy here and this guy here, it's the other factor here. Okay? So 3x squared plus 4x plus 1 is factored into 3x plus 1 times x plus 1. Okay? Next, here, you have 3x squared plus 10x minus 8. So I will guide you in the steps in here. So the steps in here. So I will guide you here. So this is your A. Let me write that. So this is your capital A, this is your capital B, and this is your capital C. That minus 8 in here. Okay? Then we need to compute AC, but capital AC, this is equal to 3 times negative 8, and this is equal to minus 24. Okay? So capital AC, it's minus 24. Remember that? So now, capital AC must be equal to small a times small b. And if we add small a plus small b, we should get capital B. So remember, capital AC, it's minus 24. So what are the pairs that we need? 1 times negative 24, but it won't give us capital B, which is 10. So this is not what we need. Another pair, it's negative 1 times 24. Okay? And this is not what we need. Negative 1 plus 24, it's not equal to 10. Next pair. Minus 24, it's equal to 2 times negative 12. Right? So 2 times negative 12, that's minus 24. But 2 minus 12, it's not equal to 10. So this is not the pair that we need. Next, you have negative 24. It's also equal to negative 2 times 12. And we see that negative 2 plus 12, it's equal to positive 10. So uh, we now have our solution. So our A, it's equal to negative 2. Our B, it's equal to positive 12. Therefore, 3x squared plus 10x minus 8, we will write it into the following form. 3x squared minus 2x plus 12x minus 8. So here, you have your minus 2. It's for this guy here. And then you have this 12. It's for this guy in here. Okay? And then we can use this grouping. 3x squared minus 2x, and then your 12x minus 8. Okay? So in here, you will have that grouping. Okay? You will have that grouping. And then we see x is a common factor in this part. Okay? So we can move it out. In this part, you have 12x minus 8. 4 is a common factor. Okay? So in that sense, we can now factor x times 3x minus 2, and then you have 4 times 3x minus 2. So you now see that 3x minus 2 is a common factor to the whole thing, to the whole expression. So you can factor out 3x minus 2 now to obtain x plus 4 times 3x minus 2. Okay? Questions so far? Question? Come again? No question. Okay? So let us work on the last example for this method. 6x squared plus 5x plus 1. So again, this is your capital A, this is your capital A, this is your capital B, this is your capital C, and A times C, this is 6 times 1, this is equal to 6. So remember, your capital AC, capital A times capital C is equal to 6. So possible small a and small b, we have capital A times capital C, it's 6. So 1 and 6. 1 and 6, because 1 times 6 equals 6. But here you have 1 plus 6, it's not equal to 5. So that's not the pair we want. Here you have 2 and 3. 2 times 3, that's still 6. But we see now here that 2 plus 3, it's equal to 5. So we need these 2 and 3. Okay? Therefore, 6x squared plus 5x plus 1, okay, can now be written as 6x squared plus 2x plus 3x plus 1. So again, we have this 2 here corresponds to the 2x, and then this 3 here corresponds to the 3x here. And now we can do the grouping. We can group 6x squared and 2x, and another group 3x plus 1. So that we will have 6x squared plus 2x plus 3x plus 1. If we look at this group, 2 is a common factor of 6 and 2. X is also a common factor of x squared and x. In this group, 3x plus 1, there is no common factor anymore. So we leave it as is. So if we factor out the 2 and the x in this group, we will write 2x times 3x plus 1. And then on the other group, you have your 3x plus 1. And again, here, there's the invisible 1 here. 1 times 3x plus 1. Which means now we can easily see 3x plus 1 here is a common factor to the whole expression here. And we factor that out, we will end up with 2x plus 1 times 3x plus 1. So again, that's the invisible 1 there. Okay? So question in this method.
In the exam, we will be the same, or
In the
it-
exam, it depends on the directions. But if you were asked to use a specific method, you have to use that specific method. If there is no specific method to use, you can use whatever you're comfortable with.
Okay, thank you.
You're welcome.
How many questions are like approximately do quizzes have with you?
For the quizzes, well, I'm not yet
Yes.
sure because there will be 3 topics there. So I will have to make sure that you can answer it within the time limit I will give. Okay?
Okay, thank you. And when will we have more information on the quizzes and how the layout is going to be?
Uh, I don't usually give the layout for
I meant like
quizzes. For quizzes.
I meant like how we're going to be doing the quiz.
You will.
Sorry, wrong
Yeah,
word.
I will send the instructions, the general instructions, either for quiz or for the midterm exam. I will send that before or on or before or on Sunday.
Okay, and just to be sure, like in the first class, you told us that certain calculators calculators are permitted, certain are not.
Yeah.
Is there any news about the Casio
You have
calculators?
you have to send me, if you have your Casio, you have to send me a picture of your calculator.
Okay, like just via Lyra? I mean Mayo?
Yeah, in Mayo, yes. I have
Okay.
responded to some of the students who already asked permission for their calculators, and it seems that uh, actually all of them were approved so far. Okay, so please let me know if you are using those models or whatever models you're using. I'll just check if you can use it during exam or what.
Okay, thank you.
Okay, yeah, you're welcome. Okay, so there's a question here: is the quiz gonna be monitored? Yes, of course. So you will open the cameras on. Okay. So anyway, let us finish the last methods here. The last method is what we call completing the square. So in this method, essentially what we're going to do, if we have an expression, okay, if we have an expression, we will try to add or subtract something so that the expression becomes a complete, a perfect square. And then there's some constant outside. So the idea is we are going to manipulate our expression, okay, to get something difference of two squares. Okay, so the idea behind completing the square is to adjust an expression to produce a perfect square trinomial and produce another form of original expression, which can be factored. Okay, for example, you have your x to the 4 plus x squared plus 1. Okay, so what we're going to do here is to add and subtract x squared. So you will have here x to the 4 plus x squared, okay? And then I'm going to subtract that x squared. So remember, if I add x squared and subtract x squared, I'm just adding 0. So it doesn't affect the original expression, okay? So I'm adding x squared, I'm also subtracting x squared. But why are we doing this? Because it will be helpful in our factoring, okay? So we look at this group here, x to the 4 plus x squared plus x squared plus 1. We simplify this, meaning we add this x squared and then this x squared here. So what we will get is x to the 4 plus 2x squared plus 1. And
I
then,
have
of
a
course, there's
question.
still the minus x squared. Yes.
Why it's x power 2? Why b?
It's the best expression that we can add.
Oh,
Actually, the choice of what you're going to add and subtract is up to you. You look at the best expression to add and subtract.
what do you mean best expression?
You could have added x and subtracted x. But the problem is, it will 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 adding x and subtracting x in the original expression help you in the factoring? You can
So
add x cubed minus x cubed. But the question is, will it be helpful in the factoring? So you have to think of the best expression to add and subtract.
in example, we always have x power 2, yeah?
Yeah, in this case, yes, we are adding x power 2 and subtracting x power 2 in this particular example.
Okay, if we don't have x power 2, we need to choose something what we have inside, yeah?
Do you mean what you have inside this
So
expression?
x power 4 plus x
No, it
power
doesn't. It
3
doesn't have to be something in this expression. You can add or subtract any expression.
or
For
any.
example, yeah. For example, you can add x to the 5 and subtract x to the 5.
Okay, that's it.
Yeah, you
Yeah,
can add
thank you.
anything and subtract anything. But is it the best expression to add and subtract? So that's your question.
Mhm.
In this case,
Okay,
if we add x squared and subtract x squared, this will be the best expression to add.
thank you.
You're welcome.
But how would we know this is the best expression to have, and how would we know it's helping us
The
factorize?
answer is no definite expression or no definite way of knowing whether what you are going to add or subtract is the best expression.
Kelvin,
You have to be familiarized. You have to be familiar in the expression. Yes.
you see plus x, I forgot, plus x to
Square.
the,
Mhm.
yeah, thank you, plus x to the square and minus x to the square.
Yeah,
This becomes, you cut it, it's gone, no?
that's true. That's why if it is gone, I am not changing the original expression.
Okay, oh
I'm
yes,
still in the original expression.
but where does the 2x to the square came from?
This one, x squared plus x squared.
Okay,
That's
got
equal
it.
to x squared.
Okay, sorry, I was just looking for the red
Okay,
color.
okay.
Okay, thank you.
Yep, you're welcome. So again, what's the best expression? There's no way to know what's the best expression. You have to be familiar with the problem. Oh, I have seen this problem, and what I did was to add or subtract this thing, and it helped me. So
Sir,
it's just entirely practicing. Yes.
can you just redo this example again? I didn't
Oh,
understand it.
sure. So in here, so the idea behind completing the square is to adjust an expression to produce a perfect square trinomial and produce another form. Take note of this. Another form of the original expression. So this guy here is our original expression. To produce another form for the original expression, you should add 0 or you should multiply 1. Okay? To produce another form of the original expression, you should add 0 or you multiply by 1. So here, I am adding x squared. I have to subtract x squared so that I am adding 0. X squared minus x squared, that's 0. Doing that, I will not change this expression. Okay? If we combine this x squared plus x squared here, this will give me 2x squared. But remember, the minus x squared is still here. So this expression is another form of the original expression, and they are the same. This x squared and minus x squared, I just took it by experience. I know that this x squared is the best expression. It's by experience. Okay? Now, I have the other form in here. If we look at this expression, this is a perfect square trinomial. Okay? That's a perfect square trinomial. Meaning, if it's a perfect square trinomial, it can be written in the following form. Your, say, y plus a squared. Okay? This is equal to y squared plus 2ay plus a squared. So this is a perfect square trinomial. Okay? If it's a perfect square trinomial, you can write it this way. So remember our first methods. The method after uh, identifying common monomial. The
Sorry,
formula that we have.
question.
Yes.
In that example,
Which one?
it's a
This B?
open no, the open bracket y plus what exactly is that thing after the plus?
A. It's
Oh,
just
okay. All right.
A.
Thank you.
Sorry. It's just A. And then this is A, this is A. Also.
It's not 2a
This
y.
is A, this is 2AY. I mean
Okay, okay.
this here, it's A.
Thank you.
You're welcome. So let us continue. So this guy here, it's a perfect square trinomial. And therefore, if you recognize this, you can write this as x squared plus 1 quantity squared. How? How? Try to look at this. This is x to the 4. You can write it as x squared. So x squared squared. Okay? So from this up to this, okay? From this up to this, try to practice. So meaning of ours, try to factor this guy here. X to the 4 plus 2x squared plus 1. Try to factor this of ours. And you will end up with this. You should end up with this. Okay? Now, let us continue. Let me give, or please, I ask you to stay like 5 minutes to finish this lesson. So you have x squared plus 1 quantity squared, and then there's still the minus x, right? So you have the minus x squared. Okay? Now, look at this. You have something squared minus something squared. So this one now is a difference of two squares. And you can factor difference of two squares. Let me write it here. So x squared minus a squared. This is equal to x minus a x plus a. So you will use this formula now for this expression as a whole. Okay? So let us continue with the slide. So you have x squared plus 1 quantity squared minus x squared. Difference of two squares, we will now have x squared plus 1. That's your x squared plus 1 here. And then minus x. And then you have x squared plus 1 in here plus x. Okay? Okay? And then let's just rewrite each of this expression in here in standard form. So you write it as x squared minus x plus 1, x squared plus x plus 1. Okay? But if you write your final answer to be this, it's totally fine with me. Okay? It's totally fine with me if you write your final answer with this. Okay? So completing the square. One last example for this. Okay? X to the 6 plus 4x cubed plus 3. Okay? So we want to add or subtract something so that this can be written in another form which can be factored easily. Again, by experience, I know that I have to add 1 and subtract 1. Okay? And that's by experience again. Okay? So you see, I add 1, I subtract 1, I am essentially adding 0. So I am not changing the original expression. So what I'm going to do now is to combine this one with this 3 and then leave 1 out, the minus 1 out. So if I do that, I will get x to the 6 plus 4x cubed plus 4 and then minus 1. And again, this expression here, it's a perfect square trinomial. Okay? So of ours again, factor x to the 6 plus 4x, oops, sorry, plus 4x cubed plus 4. So try to factor this during your off hours. Okay? And when you do that, you will get this. X cubed plus 2 quantity squared for this guy here. And then there's the minus 1 there. There's a minus 1 here. So again, difference of two squares. Difference of two squares. Which means that we can write it x cubed plus 2. That's your x cubed plus 2 here. And then minus 1 because of this. And then x cubed plus 2 plus 1. So remember that formula again. Let me write it here. So x squared minus a squared, this is equal to x minus a, x plus a. Okay? So we are just writing that. So minus 1 and then the plus 1. And then we simplify. We will end up with x cubed plus 1 and then x cubed plus 3. Okay? Now, if you are familiar with this, x cubed plus 1, sum of two cubes. X cubed plus 1 cube, which means you can still factor this guy here. Okay? So if you factor x cubed plus 1 cube, you will end up with x plus 1, x squared minus x plus 1. So let me write that. If you have x cubed plus a cubed, this is equal to x plus a times x squared minus ax plus a squared. So we are just using this formula for this x cubed plus 1. A is equal to 1. So a cubed is equal to 1 again. And therefore, you have x plus 1. That's your x plus a. Then in here, x squared minus x plus 1. A is equal to 1. So minus ax, it's just x. Then 1 squared or a squared is equal to 1. And then on the other guy here, x cubed plus 1, this is no longer factorable. Yes, you have your x cubed here, but 3 is not a perfect cube. Okay? So this now here is the complete factorization of the original expression. Okay? This method is the hardest among the methods earlier, completing the square, because you will have to be familiar with the problem to know what expression to add or subtract. Okay? Question. So let me just, so this example can also be done using the previous method. Okay? The method in what? a squared plus bx, sorry, x squared plus bx plus c. Okay, why can you do that? Look at this. You can let your y equals x cubed, and therefore y squared, this is equal to x cubed squared, and this is equal to x to the 6, which means this expression here can be written as y squared plus 4y plus 3. And in this form, I mean, you can easily solve this. You can easily factor this. So just for an illustration of completing the square, we did do completing squares here, but according to this note, you can do it this way, the easier way. Okay? So
Okay.
question. So work on as many problems as you can on pages 21 to 23 of 016 module. There's a lot of problems there. Try to practice on different methods. And yeah, that should be helpful to